Back again. Here we go. A 100 kilogram crate sitting on a concrete floor. Static. I give you static and I give you kinetic frictions. Right? I give you two of them. Static is the force it takes to get something moving. If it's static, it's not moving. So the force it takes to overcome to get something moving is what it overcomes as static friction. Once it's moving, then it has kinetic friction. So these problems, anytime you have friction, the whole idea is to do this to set up with what's going on. And that means writing net force equals. And then you list forces that are acting on it. If we're talking about the force needed, then that is a force applied. And what's fighting against it? Friction. It's going the opposite direction. So I have net force is equal to force applied minus force of friction. Okay? Now, with this problem, if we're just going to get something going, then we are going to have no net force. Another way of thinking of it is this. If I replace net force with its formula, it looks like that. Okay, what about friction? Let's replace friction with its formula. Shazam! Okay, so that is the equation we're dealing with. If you are just getting something going from rest, you are not accelerating it. So that means the acceleration is 0. Anything times 0 is 0. So this whole thing is 0. Okay, what about over here? Well, we have mu, and it's going to be it's just to get from rest. That means we're going to use the static mu, which is going to be 0.62. Shazam! Okay, then we have our mass. The mass of the crate is 100 kilograms. Bam! And 9.8 is g. So all we're going to have to do is our algebra. We're going to have 0 on one side. Okay, that whole side is 0 is equal to the force applied minus 0.62 times 100 times 9.8. So all you're going to do is add it to both sides, and you'll get your force applied and get your answer for A. Okay, what about for B? Well, the only thing different for B is once it's going at constant velocity. So this is still true. The acceleration is still 0. However, the coefficient of friction is going to be different now because now it's moving. So instead of using the static mu, we have to use the kinetic mu. So that kinetic mu is 0.55. So we'll multiply that out and then work our math and then get the answer there. What about C? Well, the only thing different with C is now, instead of an acceleration of 0, we have an acceleration of 3.2. So we have acceleration of 3.2, and we have our mass, which is going to be 100 again. So we have 100 times 3.2 is equal to force applied minus the other side. It is going to be moving. It's going at constant velocity, or it's going at 3.2. So now that it's accelerating, it still has to be kinetic. So we're still going to use our kinetic mu. Plug that in. You're going to add that to both sides. Add that answer over here, this whole thing to both sides. And then we will get our answer for force applied. There you go.